Ever feel like when we talk about space, we're kind of stuck in Earth's orbit? Well, today we're going to break free, blasting past those familiar satellites and taking a deep dive into the wild world of space operations further out.
Yeah, it's easy to picture space as this, empty void. But the region between Earth and the moon, what experts call it the cislunar regime, that's a whole different story.
Cislunar regime, now that has a ring to it, like something out of a space opera.
Yeah.
So what makes this area so special, and why should it matter to, well, anyone listening?
Think of it this way. We're not just sending the occasional probe out there anymore. We're talking lunar outposts, maybe even mining asteroids someday. This cislunar regime, it's like the highway between Earth and these future destinations. And just like any highway, especially during rush hour, it has its, shall we say, traffic challenges.
Hold on. Traffic jams in space.
Yeah.
Now, I'm picturing a line of spaceships, astronauts with road rage, honking those little spaceship horns.
Haha, maybe not quite that bad. But you get the idea. You see, the moon's gravity, while weaker than Earth's, it's enough to really mess with simple orbits. You can't just rely on those nice circular paths like we do with satellites closer to home.
Wait, so those graceful satellite paths we always see in the movies, those don't quite work in this cislunar space.
Beyond a certain distance, those pretty orbits become crazy expensive fuel-wise, almost impossible to maintain for long. Imagine constantly having to adjust your steering just to stay in your lane on the highway, inefficient and, frankly, unsustainable.
Okay, yeah, that paints a picture. So how do we navigate this gravitational obstacle course then? What's the solution out in deep space?
That's where these Lagrange points come in. Picture specific points in space like parking spots where the gravitational forces of Earth and the moon basically cancel each other out. It's like finding a calm spot in a raging river, a place to just, well, be.
So instead of fighting against the current, we can use these Lagrange points, these calm spots, to our advantage.
Precisely. They're not perfectly stable, but these points, especially one called Lagrange point 1, it's right between Earth and the moon, offer a kind of gravitational sweet spot.
Which means less fuel to stay in position, longer missions become possible. Sounds like this is a game changer, right? For all this future space exploration we keep hearing about.
Oh, absolutely. And it's not just about saving fuel. Think communication relays, observation platforms. A Lagrange point becomes this stable platform for all sorts of activities.
It's like setting up a base camp at the top of a mountain. You've got the high ground, so to speak. You get a clear view and a strategic advantage.
Exactly. But, and here's the thing, remember I said they weren't perfectly stable. So instead of parking, spacecraft actually get into these things called halo orbits around the Lagrange points.
Halo orbits. All right, you're going to have to break that one down for me. Sounds a little too spacey.
Picture a spacecraft doing this graceful three-dimensional dance around the Lagrange point. It's not parked, it's constantly moving, but in this very precise dance, always staying within this zone of gravitational balance.
Okay, so less parking, more like a cosmic waltz, carefully choreographed around these gravitational sweet spots. That's pretty cool.
You got it. And honestly, we're just scratching the surface here when it comes to the cislunar environment. Even the moon itself, as peaceful as it looks, can throw some serious curveballs our way.
Wait, are you saying that orbiting the moon is more complicated than it seems? It's
Oh.
just there, right?
Way more complicated. Most low lunar orbits, the ones less than 100 kilometers up, they're actually unstable. And that's because of the moon's, well, let's call it unique gravity.
Uneven gravity. I thought the moon's pull was, constant.
If only. It's the mass distribution. The stuff the moon's made of, it's not perfectly spread out. So the gravitational pull, it varies slightly across the surface.
So imagine trying to orbit like a lumpy potato. Your trajectory would be all over the place. That sounds like a recipe for disaster, especially for a lunar outpost.
And you'd be right to think so. Trying to maintain orbit under those conditions would be a nightmare. Luckily, it's not all chaos out there. There are some cosmic workarounds.
Oh, do tell. What's the cosmic solution to lumpy gravity?
Turns out there are a few special orbits, frozen orbits they call them. At specific angles, you can actually achieve a stable orbit even low around the moon almost indefinitely. It's like finding a groove on that lumpy potato where you can balance something and it won't roll off.
Talk about prime real estate.
Yeah.
I bet those frozen orbits are highly sought after. This is the stuff they definitely don't teach you in school.
Right. It just goes to show that even something as seemingly simple as achieving orbit, it becomes incredibly complex once you leave Earth's immediate influence.
And we haven't even gotten to the dangers lurking out there. Our intel suggests that space is definitely not the empty vacuum we often imagine. Not even close.
You're right on the money with that one. And it's not just the lack of breathable air. Space is full of invisible threats. radiation, charged particles, and of course, you can't forget the unpredictability of our very own sun.
Oh, right. Easy to forget, our life-giving star can be a bit of a drama queen sometimes. It's not all sunshine and rainbows out there, is it? So, what exactly are we up against in this more, shall we say, hostile environment? Like, space is this cosmic welcome wagon, but instead of cookies, it's, hey, here's some radiation, a site of charged particles, and, oh yeah, watch out for those surprise solar flares.
That's one way to put it. And while we haven't met any aliens yet, those invisible threats, those are the real deal. And honestly, way more dangerous than any sci-fi monster.
Not kidding, I'm guessing. So break it down for us. What kind of damage are we talking about here? Like those old movies where a solar flare fries all the circuits? Is that realistic?
More than you'd think. When the sun gets active, really active, it can unleash these massive bursts of energy, charged particles, solar flares, coronal mass ejections, that kind of thing. And those, they can wreak havoc, disrupt power grids, knock out satellites, even expose astronauts to some not-so-fun levels of radiation.
Okay, yeah, that's a bit more serious than a GPS glitch. We're talking potential chaos here. I mean, Earth has that magnetic field, the magnetosphere. That's got to offer some protection, right?
It does, thankfully. The magnetosphere, it's like our giant force field against the sun's worst moods. But imagine a shield constantly being bombarded eventually. There are going to be weak spots.
Which brings us to that South Atlantic anomaly our research mentioned, right? Sounds ominous.
Right, you are. Over that area, the Earth's magnetic field, it dips closer to the surface, like a dent in that shield. So spacecraft, especially the ones in low Earth orbit, they're more exposed to radiation when they pass through.
It's like flying through a cosmic storm cloud. You might make it through, but you're definitely going to feel it. So how do we deal with that, especially as we talk about going beyond Earth's orbit, long-duration missions, that kind of thing?
It's a huge factor to consider. Imagine astronauts on a Mars mission, months and months. They'd be passing through that anomaly multiple times, racking up radiation exposure. Not ideal.
That is not a comforting thought at all.
Yeah.
So what can we do? If we're serious about space, we got to have ways to manage these risks, right?
Absolutely. It's all about designing tougher spacecraft, better shielding technologies, even planning smarter missions, trajectories that minimize exposure time to those high-risk areas.
Like planning a road trip through the desert.
Yeah.
You pack extra water, make sure your car can handle the heat, and maybe you don't drive at high noon.
Right. Perfect analogy. And just like we need those roadmaps for a desert trek, when it comes to space, we need those clear legal frameworks, right? It's not just a free-for-all up there, no matter what some folks might think.
That's where space law comes in, right? I'll admit, I used to think it was kind of a niche thing.
Yeah.
But as we do more in space, it's only getting more relevant, isn't it?
Big time. Think about it. Multiple countries, private companies, everyone's launching stuff up there now. We need rules to prevent collisions, manage all the space junk, make sure everyone's playing fair.
So it's not just about rockets and satellites. It's about diplomacy, resource management, even ethics when you get right down to it. Big picture stuff.
Exactly. Like the Outer Space Treaty, it's a start. Bans WMDs in orbit, emphasizes peaceful exploration. That's the kind of foundation we need.
It's wild to think about these documents trying to set rules for this realm that's constantly evolving. We're basically writing the rule book as we go.
That's exactly what we're doing. And as we learn more about space, get better at operating there, those rules, they'll have to evolve too. Can't just set it and forget it, right?
It's like, I don't know, try to write traffic laws for self-driving cars before they're even invented. We got to get ahead of the curve here. And speaking of which, the U.S. Space Force, that's got to be part of all this, yeah.
100%. And it's not just about launching astronauts and stuff. The Space Force, they're critical for making sure we can keep accessing space, operating freely there, especially now that it's getting more crowded and, well, contested.
Yeah, our research dug into some of their core competencies, and honestly, some of the terms, it sounds like something out of Star Wars. Orbital warfare, space electromagnetic warfare. I need a glossary over here.
It does sound pretty futuristic, but these terms, they're describing real challenges, This is a whole new domain of operations, the rules are still being written, and we got to be ready for anything.
So it's not just about getting stuff into orbit anymore. It's about protecting it, defending it, making sure all those space systems we rely on, they keep working.
Exactly. Imagine GPS satellites go down, communication networks disrupted. Suddenly, life as we know it changes. Our economy, national security, it all depends on those things working up there.
It's easy to take that for granted, but we rely on space technologies so much. They're like invisible lifelines for the modern world, really.
Yeah. Couldn't have said it better myself. And the Space Force, they're the ones tasked with making sure those lifelines stay secure, operational, no matter what. That means better sensors, figuring out how to counter those anti-satellite weapons everyone's worried about, even planning for the possibility of, well, conflict up there.
That's where those terms, orbital warfare, that's what we're talking about then. It's kind of scary to think about, but we can't just pretend it couldn't happen.
Exactly. It's not about fear-mongering, it's about being prepared. We have the Army, the Navy, the Air Force. Each one handles threats in their own domain. The Space Force, they're doing the same thing, just, a bit higher up.
And just like those other domains, it takes more than just knowing the terrain, right?
hmm
Strategy, tech, international law, it's all connected.
100%. This is a team effort. Scientists, engineers, intelligence analysts, and of course, the people actually operating those space systems. It takes everybody working together.
It's mind-boggling, really, how complex space operations actually are. I mean, we started with basic orbits, and now we're talking about dodging cosmic potholes and weathering solar storms. It's a lot.
It really underscores how much our thinking about, well, everything national security, international relations, it all has to change to keep up. It's a whole new ball game up there.
No kidding. Our research mentioned something called joint functions, and I gotta admit, some of it sounded familiar, even in this context. Command and control, intelligence, protection, that kind of thing.
Right, those are like the foundational pieces, right? The
Yeah.
building blocks of any military operation, regardless of where it's happening. Land, sea, air, even cyberspace. You
Right.
need those functions to, well, function.
So even though space is this crazy, unpredictable environment, the core principles, they still apply.
They do. Take, say, command and control. Seems straightforward, but in space, with those vast distances we keep talking about, the communication delays,
Yeah.
maintaining a clear chain of command, making sure orders are received, understood, acted on, it's a huge challenge.
It's like trying to conduct an orchestra, but the musicians are scattered across, like, different galaxies, with a 5-minute delay between each note.
Now that's an image. But yeah, you get it. You need incredibly robust systems in place just to make sure everyone's on the same page, literally and figuratively.
Okay, so then what about intelligence? Like, gathering information in space, how does that even work?
Imagine a chessboard, right?
Yeah.
But the pieces are constantly moving and you can only see like half of them at any given time. That's space situational awareness in a nutshell.
So you're trying to track everything out there, good guys, bad guys, random space junk, all while this cosmic chess match is playing out.
Exactly. And it takes some seriously sophisticated tech, sensors, data analysis, and people who can make sense of it all fast.
It's like piecing together a giant jigsaw puzzle, but the pieces are floating around, changing shape. I'm getting a headache just thinking about it.
It's a lot. But that's why that intelligence gathering, it's so crucial. And not just knowing where things are, but understanding intentions, capabilities, all of that.
We need to know what potential adversaries are capable of, what they might be planning, right?
Yeah.
Can't be caught off guard up there.
Exactly. And then, of course, there's protection, which in an environment as harsh and unpredictable as space, I mean, it's got to be a top priority, wouldn't you say?
Especially with how much we rely on space tech now, right? Communication, navigation, even like banking. It all goes through those satellites.
It's all connected. So protection, it's got to be multi-layered. Designing tougher spacecraft, figuring out how to counter those anti-satellite weapons. Nobody wants to see those in play. Even having backups, redundant systems, that kind of thinking.
So have a plan A, a plan B, and a plan C because failure is not an option when it comes to space.
Got it.
You got it. Which, in a way, brings us full circle. Space operations, they're not just about the cool rockets and satellites. It's about this whole intricate web of technology, strategy, international cooperation. It's bigger than all of us, really.
It's about recognizing that space, it's not just this out there thing anymore. It's part of our everyday lives, whether we realize it or not. And as we keep pushing further, those lines are only going to get blurrier. For better or worse, space is becoming just another place where humans operate.
It's exciting and, I'll be honest, a little terrifying at the same time. But as we learn more about space, the challenges, the opportunities, they're only going to get more complex.
They are. But if we keep talking about it, keep innovating, and remember the lessons we've learned, the hard way down here, I think we can make sure our journey into space, it's a positive one. For everyone.
That's a future worth aiming for, I'd say. Unlocking the mysteries of the universe, while, not messing things up too badly down here. It's a balancing act.
Always is.
Well, on that note, I think we've done our deep dive into the wild world of space operations for today,
We've only just scratched the surface, but hopefully it's been enlightening.
to say the least. For me, anyway, I've definitely had a few aha moments during this conversation.
Mhm.
So until next time, everyone, keep looking up and never stop exploring that universe around us.